Hello, I'm Meg. Today we will introduce you the basic question about the motion of the charged particle in the electron field. Okay, so first thing, when you just solving this problem, maybe you should consider first what's the force will affect your electron, and second, you must know. Okay, it's an electron, so it's a negative charge. So the first you should know the force when an electron is inside the electron field. It will be F is the charge by the electron field. So since you are negative charge, so you must have the force opposite the electron field, right? So let's see an ink drop with the mass of the 1.3 multiplied the power of -10 kilogram, and a charge magnitude Q is 1.5 by the -13 of 10, enter the region between the plane, initially moving along the x-axis with the speed vx. So here we know it's the x component, right? So just as you do in the kinematics, it will be the horizontal projectile. What's the question? What's the vertical deflection of the drop at the far edge of the plane? Okay, let's see. Since you only have the x component, while you have the deflection, since you just affected by the electron field, you have the electron force here, right? And since the plane will provide you the uniform electron field, so you will be the acceleration. F is ma, a is the constant, so we call it the uniform acceleration motion. So what's the deflection? Maybe we can use the uniform acceleration formula. It will be V0t add the half acceleration the t squared, right? And then no y component for your initial velocity, right? So it will be 0. And how about your a? Okay, you can see the q here and the e here, and then the mass here, right? So get the acceleration first. It will be 1.5 multiply the power of -13 of 10. E is 1.4 by the power of 6. Mass is 1.3 by the power of -10. Use your calculator, you will go get the magnitude. Okay, it's approximately 1.62 by the power of 3. And don't forget, all the unit is the SI unit. So it will be the meter per second square, okay? And what's the time? Your time is decided by the x component, because since you want to pass from the origin to the end of the plane, so we know the time is the length of the plane over the x component of the velocity. So it will be, the length is 1.6 by the power of -2 meter and divided by 18. So what's this? It will be approximately 8.89 by the power of -4. And now you just plug back to the formula 1. So the delta y would be half and 1.62 by the power of -10. Sorry, the 3, right? And 8.89. The power of -4 of 10 squared. So the delta y is 6.4 by the -4 of 10 meter Or you can just say it would be a millimeter, right? So let's check the answer. Yes, it's approximately 0.64. So I hope you know how to calculate this question now. Thanks.